Use the definition of continuity to prove that the function is discontinuous at the given value of a. Sketch the graph of the function. Okay, so sketching a graph is sometimes more work than it's worth, but they asked me to do it on this one. So sometimes it looks like y equals x squared. Okay, so there's my x squared, but only when x is greater than or equal to 0. So I really only want to keep this piece. Don't keep that piece. Sorry, that's a little laggy there today. And then sometimes we've got e to the x, and e to the x is an exponential function. So exponential growth function. So like e to the 0 would be 1 because anything to the 0 is 1. And then it's exponential growth. And so it's going to look something like that. But I only want where x is less than 0 for this one. So only those values. Okay, so I'm supposed to show that it's not continuous when a is 0. So visually, it's easy to just look at that and say, yes, that's discontinuous. There's a break in the graph at 0. But we got to use one of our parts of our definition of continuity. So again, you need to know all 3 parts of those, and you need to be ready to say them quickly. To be continuous at a point, the limit from the left and the right have to be the same. Number 2, the point has to exist. And number 3, the limit from the left and the right not only have to be the same thing, but they have to be equal to what the point is. So of those 3 things, I would say number 2 works out. Number 2 is not showing that it's discontinuous. F of 0 exists. There is a y value when x is 0. It's the other 2 parts of continuity that are messed up. So I could say the limit as x approaches 0 from the left of this function is 1. But the limit as x approaches 0 from the right of this function is 0. You okay with both of those?
Yeah.
Okay. So those have to be the same. So the first part of continuity isn't being met. And really, to prove discontinuity, you just have to show that one thing doesn't work. All 3 have to work for it to be continuous. So you could either do this one, and or you could do this one. So the third one would be, well, how is the limit as x approaches 0 going to be equal to f of 0? Like this limit doesn't even exist. So the third rule also is messed up. Yep. To prove it's continuous, you have to state all 3. To prove that it's discontinuous, you just need to state one that doesn't work.
And whenever you're like, do you need to like say 1 is not equal to 0, or can you just like say the first part?
I mean, if this was a free response and you're trying to justify your work, like you're trying to explain things. So most of our stuff is set up as either multiple choice, which of course you just need to get the answer, move on, or free response, and you want to justify it the best that you can. So on this, if this was free response, I would probably say, like, I'd probably write out a sentence and say, first condition of continuity needs the limit from the left to equal the limit from the right. The limit from the left is 1, the limit from the right is 0, so first condition's not met. I mean, I would not spend a lot of time on it, but I would make it painfully obvious that that's why you thought. If you just wrote this, there's a chance that you would miss points. And when we use like released AP questions, we also use the rubric. So like, I probably know exactly what you mean, and I probably know that you know the right things, but if you don't like, if it says 1 point for this and 1 point for your justification, and like I didn't write what I said, then you can't get the point. You know, I can't assume that you know that.
On your test, you're going